You're listening to Blitz.
So here we are again with the Pioneer CT-7100. The issue that I'm having at the moment is that when I'm trying to record, basically not a lot is happening. I was trying to set the bias and the signal was disappearing, like the sine wave for the bias was gone. So it's very hard to adjust it when it's not there to look at. So anyway, I'm going to show you what's going on. So you can see the waveform over here. There's nothing happening at the moment. I've just attached this to one of the pins that on the bias adjust, between I think the left and right channel bias. It doesn't really matter at this point because we're not actually taking measurements. We just want to see what happens to the waveform, and you can see that disappearing. So what I'll do is I'll just press record, and as you'll see there's a sine wave appears. Well, it's not quite a sine wave, but anyway, it's there. So there's the signal. Now let's just watch this for a second, because what's going to happen is that's going to collapse. Now, this was a bit of a tricky issue because it's one of the sad things about the Pioneers is they don't actually label the components. When you get a Technics, there's a nice little screen print label on every component, so you know which is R102 or Q504 or whatever it is. So they don't do that, so you have to work it out, which means you've got to look at all the drawings. So as you can see, this is actually starting to fall down. Very soon that's going to disappear altogether. Go in. Okay, so there it is, it's gone. So the only clue really was basically I had to ask some people, what experience they've had, and a couple of people came back with the same thing, which is basically you need to use something like a freeze spray, to check solder joints and all that. Well, I've checked all the solder joints and they're all quite fine. I retouched a lot of them anyway, but there was no particular issue with that. But one person actually was a bit more specific and said, I bet you've got a transistor that's getting a bit hot. And here we've got two transistors. This one's okay. This one is enormously hot. And if we just blow some compressed air on this, voila, we have some signal back. So it would seem that we're getting to like a thermal limit, and then it's just cutting out, and then it's coming back. Now, is it a faulty transistor, or is it something sort of up or downstream that's sort of, allowing too much current to pass through? Well, it's a bit hard to tell. But what I'll do is I'll go get a new transistor for that, and as luck would have it, I never have things like this that I need on hand, so I have to go and get a replacement for that. And once we've put a new one in, we'll have to basically test it and see what happens. So this is about to collapse again, and then we'll just repeat the process, and then you can see that, basically that is the problem. And that sort of timing matches in the first tape that I tried to record. I reckon it got about half a minute or 40 seconds before it just disappeared, and then on the tape there was nothing. Okay, just a little bit of a close-up look here at the two transistors in question. So this one seems to be fine. This one here gets very, very hot. In fact, that's very hot right now. So as you can see, there's a couple of adjustments. There's a metal and a chromium adjustment, and that's, I think, for the erase head, current. and then you've got your left and right bias over there. So basically most of this circuitry in here is to do with the bias adjustment. Okay, so I'm back. I've got some new transistors. I think the only thing to do really is just let's get these out. Just put a little bit of paint on there just so that we know that that's the bad one. We can't get it mixed up with anything else. So without any more faffing about, let's just get it out. Alright, that looks alright. So I guess the only thing to do now is to basically connect it back up and check that it works. Alright, so we're set up basically as we were just before, and I think the only thing to do now is let's just test and see whether we get a nice sine wave and whether it collapses or not. Alright, there's something happening. Let's see whether that stays or whether it succumbs to heat. And obviously if this heat's getting into that again, then there's obviously something else that we need to look at. Okay, well this has been recording now for a couple of minutes. It's a 10-minute tape, so 5 minutes each side, and it's actually probably getting close to the end now. I changed the two transistors as we saw before. That seemed to change which one actually got hot, and then I changed these 4 film caps. Now when you measure the capacitance, they seem to be okay, but for whatever reason, changing those 4 is giving me that nice signal there. It hasn't gone away yet. The transistors don't seem to be getting as hot. Oh, I can still keep my finger on those, so that's, you know, they're warm, but they're not so hot that I don't want to, you know, burn myself on them. So I don't know exactly what's wrong with these, but obviously something. So anyway, they're gone and replaced, and that was, I think they were probably only about, I don't know, like 20 yen each or something like that, so probably money well spent. I'll just leave those new transistors in. There's no point in swapping them out or doing anything like that. They were probably a little bit expensive, I suppose, at 80 yen each, but you know, overall, who cares? It all adds to the reliability of this machine at the end. So quite happy with the result right now. There we go, we're coming to the end, and that's just been giving me that nice, well, semi-sine wave for the entire time. Unbelievable. I'm going to rewind and do that again because I want to be sure. I think the thing about this is that generally people seem to assume that film caps are pretty much, you know, they'll last forever, or polycaps will last forever, and you know that might be the case, as they might have a lower failure rate, but they can still go bad, obviously. So there's something wasn't quite happy in there, and we've got a bit of flakiness happening here now. So what's going on? Ooh, it's getting a bit hot. So something's semi-fixed and something's semi-not fixed. Wow. So there's still more to do. but we're slowly getting there. So there's still a couple of more, I think, film caps around that path that I'd like to maybe get rid of. I've got 2 more here, and then I need to maybe have a look in the parts bin and see whether I've got any more that might suit. But anyway, it's definitely an improvement. So something is going on in there, and it does have something to do with some of these caps. Some of these film caps are dead and dying. Potentially resistors as well, but I checked a couple of those and they're measuring with the values that they got on them, so I don't know now. That is collapsing, but gee, this is way slower than it was happening before, and we've got a long way through this tape now. Alright, so I might have made a little bit of progress here with this CT-7100. I did a bit more poking around, and I think I may have found the problem. But because that'll need, we'll need to reposition the camera so you can actually see what's going on, we'll show you the result first. So press record, and if you look here now, the sine wave actually looks like a sine wave. Maybe you can remember from the previous clip that actually it was a little bit skewed and not actually a very nice looking wave. Now I'm pretty confident. I tried this last night and that stayed like that for, well, till the end of the tape. It's only 5 minutes each side, but it didn't collapse. Nothing seemed to get too hot. So it seems like the culprit was actually a small film or poly cap, and like I said, we'll look at that a little bit in a minute. Now I didn't have the right value for that capacitor, so I just put something in, and it's working, albeit maybe not quite at the right frequency at the moment. Okay, well basically in the center here, this little capacitor that I put in here, what was in there seems to be the problem. Now it's supposed to be a 1.8 nanofarad, and I installed the closest thing I had, which is a 3.9. Now the other issue with the one that I've put in there is I don't think it's got the correct voltage rating. The spec for what's supposed to go there is 100 volts, and I'm pretty sure that that's not 100 volt. However, it's not the permanent fix. I'm obviously going to get the correct value and the correct rating to go in there, and I'm going to replace, actually, there's not actually all that many of these polys in there, but I'm going to replace the rest of them anyway, because we've had improvements by replacing a few over here, and also obviously removing that and then putting it in seems to be making quite a big difference. Okay, well let's see, what does our capacitance read? 4.5. Now this is actually very strange, because I did this a couple of times, probably 3 or 4 times last night, and it just didn't register as a capacitor at all. Now let's flip it over to ohms and just measure the resistance across it. We're getting like 4.8. I think at one point last night I read 3.7 or something like that. So clearly there's something not right here. Because if I do that with those other capacitors like I replaced it with, it will read pretty much the value it's supposed to, and when you put it onto resistance you get a 0. You get no. So that, plus the fact that the sine wave seems a lot cleaner, it's not skewed, I think that may be our issue. So anyway, I thought we'd just have a look at what that looks like. Okay, here I am with a slightly better view of this section of the circuit. Now, pretty much all of this around here seems to be concerned with the bias. So basically that's where I've been directing most of my attention.
Blitz.